Okay, as promised, this is the last video for problem 7 on side 2 of the worksheet. So it says huge quantities of sulfur dioxide are produced from zinc sulfide by means of the following unbalanced reaction. Now that one is actually the one I had on the other side of my paper, where we have 2 zinc sulfides plus 3 oxygens yields 2 zinc oxides plus 2 sulfur dioxide. So huge quantities of sulfur dioxide are produced from zinc sulfide by means of the following reaction. Now it has to be sulfur dioxide because, it has to be sulfur combined with oxygen to make sulfur dioxide. There's no decomposition reaction where zinc sulfide would be able to make sulfur dioxide without any oxygen being involved. So if the typical yield is 86.78%, how much sulfur dioxide should be expected at 4,897 grams of zinc sulfide are used? So the first thing would be 4,897 grams of zinc sulfide. That's my first step. Now, going to my periodic table, I need to go get it again. But going to my periodic table, I have zinc, which is 65.3. So 65.3 plus 32 is 97.3 grams. I could have actually looked at that on the other side. 97.3 grams over 1 mole. My grams cancel out. So I get, I have to plug in my computer. Hold on one moment. Okay, sorry, I'm processing the other videos, which meant I had to run and get my computer plugged in. But I have 4,897 divided by 97.3, which equals 50.3. We'll call it 50.3 moles. 50.3 moles of zinc sulfide. Now what's the question asking? How much sulfur dioxide should be produced? So now I have my moles of zinc sulfide, and I need to find out how many moles of sulfur dioxide would be produced. Now again, the nice thing here is I have 2 moles of zinc sulfide and 2 moles of sulfur dioxide. Which means it's a 1-to-1 ratio, 2-to-2. Either way, it's 50.3 moles of sulfur dioxide. Now it says the yield is 86.78%. Sulfur dioxide is a gas. I can do it one of 2 ways. I could do moles to liters, or I could do moles to grams. It doesn't ask specifically what the amount. Either way, the gram mass or the liter mass is going to be the same. I think I'll turn this into grams just because that is more common. So it would be the gram molar mass of sulfur dioxide. So we have 32 plus 32 is 64 grams. So 64 grams times 50.3 moles is 3,219.2 grams if it were done perfectly 100% yield. Now again, that is an exaggeration of significant digits. I really couldn't and shouldn't go really more than 3, but yeah, really shouldn't go more than, actually shouldn't go more than 2 with my 64, but I'll just make it a 3, okay, because that's going to be a nice number, fairly close to what I should be getting. So the typical yield, that's my perfect situation. So typical yield, percent yield is 86.78, and then that would equal the actual x over the theoretical, which is 3,220, and then times 100, which means that I do my manipulation. The other way of doing this is just so you can see that, the other way of doing this is taking, so times 100. The other way of doing this is just taking 86.78% of 3,220. In that case, it would be 3220 times 0.8678, which would equal, this is the same value as my x. That just is a lot more complicated, but it is 3220 times 0.8676, which would give me 2,790 grams would be my expected yield, typical yield in this reaction. And with that, we are done. Both worksheets, we've got it all completed. Looks good. I'm making sure I circle my answers. Alright, great. Hopefully that's some good limiting reactant and percent yield practice for you. Thank you for watching.